Hello everyone, welcome to my channel Mathenthusiasm. Today we're going to look at a polynomial equation of degree 5. We call this a Quintic equation. Actually, there's no simple formula to solve general Quintic equation. However, for some special types, such as the problem here, we can still figure out the solution in terms of radicals. In this video, I'm going to walk you through number 1, how to solve for the real roots of the equation. And number 2, how to prove that there's only one real root. Let's check it out. First of all, there are some missing terms in the polynomial. Let's add x cubed and subtract x cubed at the same time. Now, we can group the first three terms together. For the last two terms, take out the negative sign, so it is negative bracket x cubed plus 1. By doing so, we can factorize both brackets. For the first one, we take out the common factor x cubed to get bracket x squared minus x plus 1. For the second one, it is a sum of two cubes. By the identity, we have bracket x plus 1 times bracket x squared minus x plus 1. Do you notice something? Right, there's another common factor x squared minus x plus 1. We can further take it out. So inside the second bracket, it is x cubed minus bracket x plus 1, which is x cubed minus x minus 1. At this point, it is obvious that either bracket is equal to 0. Let's solve them one by one. For the quadratic equation x squared minus x plus 1 is equal to 0, we can check the discriminant. It is b squared minus 4ac, which is smaller than 0. So there's no real root. For the cubic equation x cubed minus x minus 1 is equal to 0, it is in the form of x cubed plus px plus q is equal to 0, with no x squared term. This form is very nice because we can use the Cardano's formula. It is a sum of two cube roots. Both of them are in terms of p and q. Let's put p and q equals to negative 1 into the formula. After simplification, we get the exact values in radicals. This is approximately 1.325. So why is it the only real root of the equation? We're going to use calculus to explain it. Let's look at the graph of f of x is equal to x to the power 5 minus x to the power 4 minus 1. To figure out the special points and the behavior of the graph, we differentiate first. So f prime x is equal to 5x to the power 4 minus 4x cubed. Factorize it, we get x cubed times bracket 5x minus 4. When f prime x is equal to 0, x is equal to 0 or 4 over 5. Using the first derivative test, we get the signs of f prime x in each interval. Let's look at x is equal to 0. The sign of f prime x changes from positive to negative. So the graph is increasing and then decreasing. In other words, there's a maximum point at x is equal to 0. Likewise, we find that there is a minimum point at x is equal to 4 over 5. You may wonder if it's alright to use f double prime x. Actually, it doesn't work for x is equal to 0. You can calculate that easily. Let's solve for the y coordinates of the 2 points. F of 0 is equal to negative 1, and f of 4 over 5 is equal to this value. Both of them are smaller than 0. Now, we have a good understanding of the graph. Let's look at the graph of this function. There are two important parts. Number 1, both the maximum point and the minimum point are under the x-axis. And number 2, when x is larger than 4 over 5, the graph is increasing. There are no more maximum nor minimum points beyond this part. So the graph intersects the x-axis at exactly 1 point. Now, we can make sure that there's only one real solution of x such that f of x is equal to 0, which is the value we obtained from the cubic equation. Pretty nice, isn't it? If you want to know more interesting questions of algebra, please check out the links of the videos and the playlist on the screen and the descriptions below. See you in next video.